Hello, so hopefully this is a short cautionary tale for anyone that's had a van converted by Sugoi Campers in Fareham before they went out of business, or for anyone that just likes looking at crappy electrical installs on vans. I suppose you might find this interesting too. This is just a list of horrors that I have found in this van that was converted in 2024 before they went out of business. So the first one I wanted to talk about is unfused cabling. So we've got starter battery in the front, we've got leisure battery in the back. As the van came, there was a panel up here which has some breakers in it, but then actually one of the cables here, this guy, was completely hidden from view, and I didn't see it until very recently. This was coming off the battery terminal, and off it goes into the van. This has got, you know, hundreds of amps behind it, if not thousands of amps when it's fully charged. And this cable, 16 square millimeter, unfused, runs all the way through the van. Think of a side impact perhaps coming here on the B pillar. This cable is traveling by all these edges, coming in at floor height. It's going to get trapped between the B pillar and the floor, all the way back here, all the way up past these edges, through these gaps, up over the top of the rear wheel arch, and then coming back here to, oh, a breaker, finally. This should be in the front, this shouldn't be in the back. All of this cable, if this gets involved in an accident, if it gets pinched anywhere on any of these edges, if it wears through, like look at that unprotected edge that's rubbing against, if it wears through, that entire length is going up in smoke. Number 3 on the list is undersize cables. The inverter was coming out on 25 square mil through 150 amp breaker. The other main outgoing line from the leisure battery was the unfused 16 square mil cable, which was going back to the leisure circuits. And then it's all coming back through this one epoxy little 16 square mil cable. This is maybe good for 100 amps, and we've got that circuit protected to 210. On the outgoing, I found this because it was getting disgustingly hot. It was actually hidden behind the breaker panel, so the breakers were here, but I was just feeling around while we had a camping kettle on and found that to be incredibly hot. I think if I ran that for much longer, that would quite potentially have gone up in flames. Another bit of a strange undersized cable is the current return path is coming down through the protective earth bonds back to the chassis of the car. So this cable, what is it, 2 or 3 square mil, is protected to 60 amps of that breaker. This black cable here, by the way, this is the ground for the mains charger. So the second one to watch out for, and unfortunately these are all hidden behind PVC electrical tape, is really poor crimping of these tubular lugs. I just pulled that off, and that is actually one of the better looking ones. And here we have the horror show. Let's start over here, shall we? I mean, this one's merely had the hint of a suggestion of a crimp, but I'm not sure what that is. That's part of the split charge circuit. These two here, what are these? These are the 25s. These are from the inverter circuit, so these have up to 150 amps going through them. It's a 1.5 kilowatt inverter, so a bit less than that, but check that out. So they've got that caught in the crimping tool, and carried on, signed it off anyway. So what will happen here is it's crimped up this bit incredibly tightly, and the rest of it's probably pretty loose, and I have had it, yeah, there we are, that one. So that's exactly the kind of failure we're talking about here, is that the copper gets crimped in the small area that got caught in the crimping die, and it does not crimp through the majority of the cable. So these cables down here are not in proper contact with the lug. Risk is overheating and fire. Check this guy out. This is the chassis end of the grounding cable for the inverter. It's mostly whole. I mean, kudos for drilling accuracy. And it's worth noting, I've just come to the seat subframe. This was actually trapped underneath one of the bolts that holds the bloody seat in. This mostly whole copper washer. So unfortunately, this is going to be a difficult one to spot, because these were all wrapped in electrical tape. I had to take each one of them off. A few of them are really obvious, like you can see that through electrical tape. You can see it a mile off. They didn't know what they were doing, frankly. Whoever did this didn't have a clue. So the fourth one I'm going to mention is poor grounding. This is where the inverter was mounted. It's quite a nice spot for it. It's in the passenger seat subframe. Lovely. Had a 25 square mil ground cable, so it matched the incoming, so that, you know, not terrible. Again, a bit skinny. And then it was grounded here at the back. So they've made some effort to create a ground connection here by taking the paint off. So they've at some level know that's important. But then the weird thing is there's nothing between this and the rest of the van. So no paint's been taken off on any of the mounts, and nothing has been done to create, sorry, that's a magnet. Nothing has been done to try and create a 150 amp suitable ground from this frame into the van. And we were struggling with inverter performance, actually. This thing was running down and giving us low voltage alarms well before the leisure battery was reaching the voltage that was claiming to have reached. And this is probably where the majority of the voltage drop was. So the last point is going to be a big one, but I'll try and rattle through it as quickly as possible. There's two ways to get 230 volt AC mains onto the van. One is the inverter, so 12 volt to 230 volt inverter, and the other is a camping hookup. Now, the first thing to note is something to check. Do you have an electrical install cert? Because we do not. We need one. It's a fixed install, and what with everything else that was going on at the time with all the returns in this van, I just completely slipped my mind that we should have one. We don't have one. There's probably a reason for that, and we will get onto that shortly. So the second point, well, second sub point, I suppose. This one's going to have to be broken down at sub points, unfortunately. I couldn't quite figure out how this system was safe when I was poking around with it, so I emailed SEC UK, and they were super helpful, actually. Their response was great. This inverter is not meant for fixed installation. It's what's called a floating output inverter. What that means is that the live and neutral are completely floating from the input and from the case, and this is important to note. I'll come back to this. On the outputs, the earth contacts down here between the two sockets they're not common, and they're not connected to the case. So it is a isolated inverter. In their words, not intended to be hardwired, is what they told me. And Sugoi bought one and hardwired it in, and there's some problems with that. So at this point, I've just jumped into the back of the van because this is important. This is the output of the inverter, so the other end of the plug that was plugged into the inverter, and this is the incoming from the camping hookup, and that actually goes through an RCD first. This is the changeover relay, and the important wire here is this guy. So this is a neutral earth bond. You can Google that if you don't know what that is. But the inverter neutral goes around the outside here and is bonded to earth, which is via the earth bar up here, bonded to the chassis of the van. That's going to come in important in a second. But effectively back here, what that means is that this socket here, which came out to the sockets in the back of the van, this RCD will work just fine. So everything in the back of the van is great. If there is insulation failure to ground in the back of the van, this RCD will pop. All is safe. Lovely. Question is, has that just fallen out? Lovely. So in the back of the van, we're protected. The question is, what happens up the front of the van? What happens when there's a fault in the inverter? So I've checked all around the inverter. It's not double insulated. It's not class 2, I think is the terminology for it. So when it's installed into a fixed installation like this, you need to assume that the case can go live under a failure situation. So if a little wire comes off inside or whatever. So the important thing about that neutral earth bond at the back of the van is if this goes live, if there were a proper connection on this, on the case, to the chassis of the van, what happens is that current travels from the case to the chassis, back to neutral through the neutral earth bond, and back into the inverter here. So it effectively short circuits the inverter, and the inverter will go into a protection mode. It'll detect the short or the overload, and it will shut down. Lovely. So the inverter case has to be earthed. Now remember I said it was a floating inverter. It wasn't supposed to be fixed and installed, and it didn't have an earth bonding point on it. So what Sugoi have done here is they put on an extremely dodgy earth bonding point. Now, as to if they knew why they were putting that on, I don't know, but the end result is not great. If I just unplug it and flip it over, so we have got on the underside, they've taken off a bit of paint, so you know, you knew how to do that. And then what's happened is this has been trapped underneath this mount. So it's not underneath a bolt head, there's no star washer, there's no kind of positive lock in there. You can see where it was sort of indenting into the wood here. That's a poor connection, that's not good. This is safety relevant. The other end, back in this corner with our friend from earlier. So it's connected to, it's got an earth bond to the seat subframe, great. But there is no earth bond from the seat subframe to the rest of the chassis of the van. So considering this is a protective earth, which is going to protect you from shorts to the case of the inverter, that's a really poor bit of workmanship there. Watch out for that. And also note, it's not necessarily true that this end plate, this case and this end plate are all electrically connected. It's a floating inverter, so they're not required to be. So to be honest, what it probably should have, even though we're kind of in a world of pain here already because this is a floating inverter, it's not meant for permanent install, there should be some kind of a proper galvanic connection between all of the bits of metal on the outside of the case back down to the actual chassis of the van in order to keep this safe, which it doesn't have. It just has that one dodgy wire trapped underneath the inverter between it and a bit of wood and bonding it to the seat subframe. So fine, you could argue that maybe this would be good enough, perhaps. I doubt it would pass an inspection, but maybe it would be good enough to keep you safe in the event of the inverter shorting to its case. What it isn't good enough for, this socket is available to use. So as supplied, this just had a magnetic cover over it. Easy to access, super convenient. This is actually what we were using to power things in the awning of the van. It is not protected because of what I said earlier. It's a floating output. These earth pins are not connected inside. So on this side of the inverter, there is no neutral earth bond. So that means it doesn't matter if you put an RCD here, it's not going to detect any faults. So if you have, say, a camping kettle, a cheap metal camping kettle, as many people do, as we do and have been using, if that kettle suffers an insulation failure and the case of that kettle goes live, there's nothing this can do about it. The kettle will be live and it's not double insulated, so you have to expect it's going to go live. The van, because of the neutral earth bond on this side, will be at neutral potential. So you've got a situation where you can put one hand on the kettle, one hand on the van, and you're dead. Frankly, you are dead. That's 230 volts across your body. As I say, there's no way this would have passed any kind of an inspection from a proper Sparky. I don't think this has been thought through at all, frankly. Just powered it up on the bench, 234 volts. So it does have an open ground. As I said, RCD test, nothing, not a sausage. So yes, correct to say that there is no RCD or ground fault protection in this unit. So I'm going to wrap things up there. If you're still watching, I guess you got one of these vans, or one of the vans converted by Sugoi, and you're concerned about it. I really hope you don't have anywhere near the level of issues we had in this one. As I said, we were involved with them right at the end of their business, and who knows what was going on. But yeah, this is a complete dog's breakfast. And we are going camping next weekend, so I need to get this back together. I hope this has been helpful anyway. Cheers.